All right, so polynomial basics. All right, the first thing we're going to look at doing today is we want to be able to add and subtract. Can't spell. Subtracting. Okay, polynomials. Okay. Adding and subtracting polynomials is pretty easy. The biggest thing you want, the big thing you want to keep in mind is it's just combine like terms.
Wait,
okay.
When do we take our final for this class? Do we have to take a final for this class?
The final was, so there is no like final for this class. We had the 2 CREST benchmarks.
Okay.
So the reason, so we took the first CREST benchmark, which was the first third of the class. The second CREST benchmark was the second third of the class, and then for the final section, there is no benchmark. With the idea being that at some point we're going to maybe have a park that we would take, and that would kind of like cover that.
Are we taking a park?
There is no park in geometry yet, so kind of thing.
All right.
Okay, that's good, and we'll see if there ever will be one. Who knows? Really, we don't know. Okay, so. Because for whatever reason, the powers that be feel like algebra is a bigger, more important thing for you guys to have, tested and than geometry, for whatever reason. Which on one hand, I'm like geometry is important too, but on the other hand, I'm like, but that's good. We don't have a test, so. Anyway, all right. Adding, subtracting polynomials, just combine like terms. So let's talk about like terms first of all. Let's refresh our memory. Okay. So looking back at the warm-up here, right, that first 3, I guess I should say, okay, what made these 2 numbers here, the 3 and the 4x, what made these not like? What's not the same about them? Okay, yeah, they both have numbers, but one has an x and one does not. So for there to be like terms, it must be same variables. Actually, I'll put same variable or and then in parentheses variables, right? Because sometimes you have more than one variable. So if you have an x, the other thing better have an x. If you have a y, the other thing better have a y. If you have a q, the other thing better have a q. Or if you have an xy, then the other thing better have xy. Okay? So same variables and, okay, the second thing here, so why did Maddie correctly identify here that these 2 were not like terms? Different exponents, right. So it has to be same variables and same exponents. Okay, if you have those 2 things, you got like terms. Zarius, yeah, come on over. Okay, so that's all there is to that. Okay, those are like terms, right? You don't add apples and oranges because they're different things, right? You don't add x and y, they're different things, okay? I guess you could add apples and oranges, and you can say how many pieces of fruit you have. But anyway, we keep them separated. Okay. So we'll take a look here at some questions. So let's just start out here with some examples. Okay. And we won't spend a lot of time here because I feel like this is something that you guys have down pretty easy here. So 3x plus 7 plus 2.
So we finish over units
minus 2. For the most part, yes. I'm leaving out some stuff, but I feel like this is going to be more beneficial to you. So I'm making kind of like a executive decision here to do this instead, because I think it's going to benefit you more in your near future than the other stuff would potentially. Okay. So yeah, we may do another little bit of geometry. I'm not sure. Next week. I'm not sure what we're going to do next week exactly. What's that?
Is there geometry too?
No, exactly. This is the only geometry, only specific geometry. Now, in Algebra 2, there will be sections, like in fact, you guys will see like trigonometry again in Algebra 2, for example. I know that's there. Okay, so like sine, cosine, and tangent, those are not gone yet. But anyway.
So is there geometry too?
That's what I...
Yeah, no, there is not. There is not. I mean, not in high school. Now, should you continue on your studies and stuff like that, yes, there are like, more advanced geometries, but nothing that you have to worry about in high school. So, anyway, okay, so like terms here, right? So let's see, I don't know. So Josh, I mean, you know, what does this end up being when we do this? What is this simplified to? Yes, very good. 5x minus 3, right? The 7 plus the negative 10 there, right? We can treat that like we're adding a negative 10. So 7 plus negative 10 becomes negative 3. So it's 5x minus 3. And good, Josh put it in the normal order too. Okay, that's not the only way you have to write it, right? We could write, what's another way I could write that besides 5x minus 3, and it would still be the same thing? So, good question. Is this the same thing?
No.
It's not, is it, right? Why isn't this the same as this? Yeah, the 3 should be negative, the 5 should be what? Positive. So if he just fixed it though, now is that right?
Yeah.
Yeah, that's right. Okay. So now Derek brings up a good point. Okay. He would be right for other kinds of answers. So let's change it up here. Let's say this was 5x plus 3. Would he be right if we flipped around and said 3 plus 5x?
Yeah.
Yeah, so addition, you are allowed to flip around and still be the same thing. Okay? What other operation can you flip the order and it'll still be the same thing? Yeah, multiplication. Now what about division? Can you flip the order of division and still be the same thing?
No.
Yeah, no, okay? So, if it's kind of interesting here, multiplication and addition are like, although we treat them, you know, we always say, you know, add, subtract, multiply, divide. We put them all together, lump them all together. But actually, multiplication and addition are two kind of slightly separate operations. They're kind of different than subtraction and division. I mean, you can see it right here, right? Or not here, but as an example. You can't flip around subtraction, but you can flip around addition. You can't flip around division, but you can flip around multiplication. So it's kind of interesting. They're actually two kind of different operations. And in fact, really, we don't ever need subtraction or division, right? Because any subtraction problem, you can change into an addition problem. And any division problem, you can change into a multiplication problem. So really, we don't even need the operations, subtraction and division. We can just use multiplication, addition for the whole thing. Anyway, that's a lot of other stuff there, too. All right, let's try another one here. Let's try this one. Okay. So this is also these are two polynomials that we're adding together.
Is the last one where it says 5r, is that like cube?
It's a square, sorry, I know. I need to write these bigger for you all. Actually, I can zoom in some too to help. Can I do it one more? Ooh. Yes, just barely, but it fits. Okay, so there's our next one. Now, by the way, right, in the first example, we added a binomial and another binomial, okay? Why do we call these two things binomials? There's two terms, right, okay? There's two monomials being added together, two monomials being added together, okay? And then, what we call this thing then? A trinomial, okay? So tri means three, right? Triangle, three angles, three sides, right? So trinomial has three. So there are two trinomials being added together, okay? All right, very good. Let's see here. So, Jaden, do we have any like terms in this problem?
Yeah.
Okay, what are some like terms here? 9r cubed. Yeah, and we have a minus 8r cubed. Don't forget to look in front of that sign there, and we're adding those. Okay. So what is 9 plus negative 8? Or really, I guess you can think of it as 9 minus 8. What's that going to be? A 1. Yep. So 1r cubed, or we don't have to put 1. We can just put r cubed, right? So I'll put that. Okay. If you want to put a 1 in front, though, it's not wrong. All right. Very good. And I'm going to like cross those out just because sometimes when there's so much going on, I'll cross them out just so that way it kind of keeps organized and I don't have to like worry about, what to look at and stuff. All right, Jaden, what else?
11r.
Okay, 11r, 9r.
And then
Okay. And so what does that become? Yep, 20r. Okay, so we're adding here, right? Plus. So 11r plus 9r. When I say 11 oranges plus 9 oranges, I don't say that I have 20 oranges squared. I say I have just 20 oranges. So it's still, we're just adding. If we were multiplying though, Jason, then yes. All right, last thing, Jaden. What else do we have here to combine? 5r squared and negative 2r squared. That's right. 1, 2, 3, 1, 2, 3, like that. Boom. So we get plus 3r squared. Okay. Right. So this is not the traditional order, but is this a wrong order? No, this is still okay. But Akeva, I'm assuming. Well, actually, go ahead. What did you do? I bet I know what you did, but you probably.
Exponents and then 3, 2, 1.
Yeah, exactly. So you did r cubed plus 3r squared plus 20r. Okay, and that's fine. These are both equivalent, but you can absolutely put them in descending order is what this is called. This is called descending order. Okay, but either one is fine. Okay. In general, though, when you do them, like, in general in mathematics, okay, these are both correct, but in general, we normally write them in this order just because, that's just how we're used to writing them, I guess. Okay? Let me do one more. Actually, I might do 2 more here because I got to do some subtraction ones as well, right? So. Okay, so now I'll do some subtraction here.
Is it the same concept?
Similar idea. Yep, exactly right. Same idea. The only thing we have to watch out for now is that we are subtracting these things. So I'm not going to take 3x to the fourth and add a negative 3x to the fourth here. We have this minus sign in front. Now there's 2 ways to kind of do it. You can just say, okay, it's 3x to the fourth minus negative 3x to the fourth, but I think that's too much to kind of keep track of. And so what
like 3x plus 3x. Wait, 3x plus 3x.
So,
2 negative.
exactly right, Ramel. Yeah, so Ramel's got that down, and that's good, okay? And then just to kind of help you guys see this even more, what I would say is, when we have a minus in front of parentheses, right, anytime you have a number in front of parentheses, you can distribute that. Well, you can also distribute the minus sign if it's in front of parentheses too, and you should distribute it. So minus that. So I'm going to rewrite it before I do anything. I can drop the parentheses here since there's nothing to simplify. I can kind of drop them, okay? And then minus 3x becomes minus 3x, and then minus a negative 3x to the fourth becomes plus 3x to the fourth. Okay, the signs kind of change. Yes.
Would 6x4 minus 6x, would that be right?
Yes. So yeah, our like terms then here, we have a 3x to the fourth and a plus a 3x to the fourth, right? Those are like. And so we get 6. I got to scoot over here. I'm going to run out of space. 6x to the fourth. Okay, right? And then minus 3x becomes minus 6x. And so there's our like terms. Okay. All right. I'll do one more here, and then I'll have you guys try one, and then we'll move on. Okay. So let's see. All right. So let's try 5y cubed plus 4y to the fourth minus y to the fourth minus 4y squared. Oh wait, I want to do 4y to the fourth, sorry. No. Sorry. Okay, there you go. Sorry, I made a mistake. So it should be 5y cubed plus 4y to the fourth minus y to the fourth minus 4y cubed there. So just kind of ignore that little thing in the center. All right. So there's that one. All right, so let's go to, Garrett, got any like terms here? Yeah, but first, since we're seeing subtraction, what can I do with that subtraction sign? Yeah, so I'm going to distribute it to those and to those. So this stays the same, 5y cubed plus 4y to the fourth. Now this is going to become what? Okay, sorry.
So what you say?
So the minus sign distributed to the y to the fourth becomes what?
Negative y to the fourth.
Yep, minus y to the fourth, or negative y to the fourth. And then minus y, 4y cubed becomes what?
That'd be, add.
Yep.
Negative, or would that just be add?
It's just plus, positive now, 4y cubed. The negative and the negative cancel out, become positive 4y cubed. Okay. And then that equals, what's that equal then, Garrett? Now we can add those like terms. Okay, sorry.
So you do 4y to the fourth, and would you do negative versus negative y to the fourth?
Or minus y to the fourth, and what does that leave us with then?
3y.
You got it, 3y to the fourth, right? 4 oranges, take away an orange, you're left with 3 of them. So 4y to the fourth, take away a y to the fourth, you're left with 3y to the fourth. Yep. Anything else to combine here?
Yeah, and then you do minus y to the cube to plus 4y cubed.
So that's 9y cubed, right? Anything else we can do here? Any more like terms?
No.
Yep, that's it. We're done. That's as simple as we can make it. Yes.
Is it okay that I don't distribute? It's
Like you don't, yeah. If you have it down like another way, as long as you're getting it okay, that's fine. Yep.
Why is it positive?
Why is it positive 3y to the fourth? Because it was plus 4y to the fourth, take away 1y to the fourth. So 4 minus 1, positive 3y to the fourth.
Oh, yeah.
Okay? Alright, let me give you 2 to try here on your own real quick. Alright. Alright, so we'll say 6m plus 3 minus 6m plus 2, and then that's the first one, and then the second one here. What do I want to do? Yes.
What happens like in a problem if you get 0?
So it's gone. Those they cancel out. It's eliminated. Okay, so go ahead and give those 2 a try. Combine like terms on those, please. Okay. Kind of want that. Let's give these a shot here.
That's the same thing.
Are they like terms? They're not. So it becomes then a minus 6m. Like a minus 2 then, because a minus times a positive is negative. So minus 2. You ready, Luke? Yes. Yeah, good job, Mel. That's right, good job.
How about this?
Oh, you want to see that one? Yep, that's right. Isn't that crazy? Yep.
So AB is one side of the box. BC is in between the sides next to it. They're going to be like that. So again, because it's a rectangle, it's going to have a right angle. So if one slope is kind of positive, and to make that right angle, the slope right next to it is going to have to be negative. Yes, then combine like terms now. Once you've done that, combine like terms. So what's 6m take away 6m? Well, if you have 6m and you subtract 6m, you're not left with 1.
What is this?
Or not, sorry, you're not left with
Military
m,
score.
it's 0. But then, 3 minus 2 is 1.
That was called.
So if you have 6m, you take away 6m.
It can be it's really big.
If you have, it's not m that's left over, it's 0. So that's all. So root is 10.
So it's different.
Yes. That's right so far. Yep. Exactly right. Yes, exactly right. Yeah, that crazy? Yeah.
Exactly right.
Yes, good job. Yes, exactly.
It would just be right.
That's right.
Sorry, I gotta see what I got. Okay, so it's 3a. Sorry? Yeah, it's an a, yeah. And then it's 3a squared plus 4a squared. So 3 plus 4 should be 7a squared. Okay.
Mr. West,
Yeah.
can you run home?
Okay. And then we're going to go over this real quick. So 6m equals 6m is 0. Pretty crazy. All right, folks.
Let's take a look here. Kyle, not right now. We'll have work. I promise we'll have classwork later. Okay. If you want to put the chair down still, you'll be able to move over there. You can still put the chair down for later, but then you come back for right now. We're not quite done the notes. Okay. Thank you, sir. All right. All right. So let's see here. All right. So Kyle, did you get the first one there for us?
Wait, which one?
Number 1, 6m plus 3 minus 6m plus 2.
Oh yeah.
What'd you get?
I got 12m and 12m plus 5.
Okay, so be careful here. We're not adding, we're subtracting these two things.
Oh,
So
okay.
6m take away 6m is...
Alright, it would be m1, right?
Close. So, yeah, so this is a little bit weird because when we distribute the minus sign here, we have 6m plus 3 minus 6m and then minus 2. Okay? 6m take away 6m, it cancels out. It's 0. Yeah, those cancel out. And so then it's just really 3 minus 2, which is just 1. So sometimes, folks, we can start out with variables right, but then they disappear. So here in this case, we're just left with 1 because 3 take away 2 is 1. Okay? That one was a funky one. All right, let's go to someone we haven't heard from yet. All right, Xander, how about number 2? You got number 2 for us, sir? Combining like terms here. What are some like terms we have to combine in this problem? It's addition, so we don't have to worry about distributing the minus sign. It's just ready to go. So, for example, Xander, 3a squared, does it have a like term? It doesn't? Not in these parentheses, but over here. No, but we want to look for numbers that have the same variable and the same exponent. So 3a squared and 4a squared, those are like terms. So yeah, exponents, right? So what's 3 and 4? 7a squared, that's right. Okay, so those taken care of. All right. 5 and 3, so it makes 8. 8a cubed. And then what about this minus 2? Is there a like term with the minus 2? No, right. So we'll just have to rewrite that, minus 2. And what about the minus a? Is there a like term with that? Yeah, no. So again, we just bring that one along for the ride. It's minus a, okay? Now again, this is a fine answer. If you want to put it in descending order, it'd be 8a cubed plus 7a squared minus a minus 2. Okay, but this is fine too, or whatever, you know, potentially whatever order you have there as well. Just make sure there's a minus in front of your 2, minus in front of your a. All right, questions on any of that? All right, cool. So another thing I want to be able to work on today, or be able to do today, okay, for some practice, refresher and review. Okay, I want to talk about like multiplying. Polynomials. Okay, multiplying polynomials. Okay. Sorry, question?
I have a question as well.
Yes.
So when you
Sorry, let me scoot there. Okay, what was the question there, Jaden? Sorry. Not minus 2a, no, because again, they're different, right? This does not have an a with it, this one does, so we wouldn't combine those. Now, if we were multiplying, you can do 2 times a, that's no problem, it becomes 2a. But, you know, add, subtracting, they don't go together like that. Okay? All right. So, the next thing we're going to talk, in multiplying polynomials, we're going to start with, so first of all, we'll start with something like this. So, oh, not, sorry, let me do it this way. Okay, so now multiplying polynomials. Okay, right, so when we have something in front of parentheses, we distribute that something. So the something in front of parentheses here, in front of our parentheses, the something is 6x. Okay? So that means the 6x multiplies to negative 10x and to the 4. It distributes. Okay? Multiplication there. All right? So let's see. So 6x times, now we're not adding these things, we're multiplying them. 6x times negative 10x. Okay? And maybe I'll write this. I know you guys maybe don't normally are used to seeing this intermediate step, but I'm going to write it out. 6x times negative 10x, and then I'll write the other distribution out, which is going to be plus 6x times 4. You don't normally write this step out, right? Most of you guys probably just do it, but I'm going to write this step out. If it helps you, you know, it'll be useful to have that out. Okay, so 6x times negative 10x. Okay, what gets multiplied in this? What should we, like the 6 can multiply to the what? Yeah, negative 10, right? We want to multiply the numbers together, so 6 times negative 10, negative 60. And then, yes, x times x gives us x squared. Okay? And then plus 6x times 4. The 6 multiplies with the 4 to make 24, and there's no other x there, so it's just going to be 24x. Right? Okay, so addition kind of like breaks up the problem, right? Breaks up the multiplication. We do 6x times the negative 10x, and we add, so that breaks it up, 6x times the 4. So it breaks it up over the addition there. You kind of break it up. Okay? And are there any like terms to combine here? Yeah, no, that's x squared, that's x. We can't combine it, so that's our final answer. That's it. Okay, when you multiply, remember you add exponents. So it's x to the 1, x to the 1, so it becomes x squared. Okay? All right, let's try another one here. Yes.
When you multiply 2 x's and they have different exponents, you add the exponents.
Exactly right. Yep. So yeah, so in this one, 4x cubed, again, it's a number, it's something, it's one thing, right? This is one term in front of parentheses. We're going to multiply this thing in front of parentheses times what's inside there. Okay, like that. We distribute it. Okay, we distribute that. So, and again, because there's addition in here and we're multiplying. It's a distributive property, okay? So we distribute 4x cubed to the 11 All right, and then, so again, I'm going to write out this step. You don't have to write this out if you don't want to. It's just a little bit extra, but it's helpful maybe. And then 4x cubed times 3x squared. Okay. 4x cubed times 11 becomes what? Cubed. 4x cubed times x squared, what we can do the 4, which is what? 12. And then x cubed times x squared is x to the 5th. Right, okay. When we multiply, we add exponents. There is a situation, there is a time when we do multiply x powers to kind of, when you're multiplying the same base, you add their exponents. So x is being multiplied by x, so you add the exponents to combine them. Okay? Are these like terms? No. No. So we're done. Okay. Now, I want to show you another kind of multiplication of polynomials that we can do. Okay. Okay. The first two problems, they were like identical pretty much, except for, you know, some of the numbers were changed around, right? You can see how those kind of group together. Is this one in that same kind of like grouping as these two? Not quite, but it's actually more similar than you might expect, okay? So here, we were multiplying two polynomials. We multiplied a monomial. Mono means one, right? So if you guys ever looked around at like video games or like your computer or something like that, sometimes you can like change the speaker setting from stereo to mono. So stereo means they use the left and the right speaker, and they put different sounds out of different things to kind of make it more, you know, I don't know, sound like more realistic. Mono means they put the same output through both speakers, so you don't get like a left and right kind of thing. It's just like the same output regardless. Mono means like one, okay? So that's a monomial, and then a binomial right there, okay? And that's, you know, obviously there's two things in here. So these two, we're now doing a binomial times a binomial. Okay, but the same principle applies, if you can believe that or not. Okay, so what do I mean by that? Well, we took the thing in front of parentheses and we distributed it, right? So 6x times that, 6x times that. Okay, well, what's the thing? So here's a set of parentheses, right? What's the thing in front of those parentheses? This x plus 2. Okay, but there's two separate things here. There's two separate things. The addition makes them separate. So we're just going to distribute the x times the x times the 3. The 2 times the x, the 2 times the 3. Okay, they both distribute. Okay, and so it becomes then x times x plus x times 3, okay, plus 2 times x, and then plus 2 times 3. Okay, so that, sorry?
Would it be like 2x or x squared?
So here?
Yeah.
X times x, which one is that? 2x or x? It's x squared.
Okay.
X plus x is 2x, right? Like an orange plus an orange is 2 oranges, but an orange times an orange, well, we can't really do that, so that doesn't make any sense, right? But you get the idea, though. X plus x is 2x.
I got it right.
Okay, good. All right, so x times x, is x squared. 3 times x is, well, that's just 3x. 2 times x is 2x. I'm sorry, what was the question? Yes, so an acronym that we use for that is FOIL. Now, FOIL, though, only works for when you're multiplying two binomials. A binomial becomes a binomial. We can multiply something even bigger than this. Like I could do a trinomial, 3 terms times a trinomial, and then this kind of method would work. You just multiply everything here times everything in here. And I like to do it systematically. So x times these two, and 2 times these two. And then 2 times 3 is 6. And then are there any like terms to combine here? Yes, there are. What are like terms? 3x and 2x, and so that becomes x squared plus 5x plus 6. Yes?
Like, do you have to, like, write that all out?
No, I'm doing it very explicitly, just to make sure for anyone that, like, maybe has had difficulty with this before, just they can kind of see it all. But if you get it from, like, here to here, Caleb, do it, by all means.
What if you have, like, multiplication with the 3, like, if it's, like, another parentheses added to the 2?
So if there are, like, 3 of these things.
Yeah.
All right, I will hit on that in just a second. Let me do one more of these, and I'll talk about that, okay? All right, let's try one more here, and then I'll cut you guys loose on an assignment. All right, it's the last one. I'll give you guys your assignment. Okay. All right, so again, we have a binomial times a binomial, but again, it's something in front of parentheses, right? This whole quantity is in front of these parentheses. And so we'll just distribute, okay? Each piece here to each piece here. So 2x distributes to the 5 and to the minus 3x. The minus 2 here distributes to the 5 and to the minus 3x. Okay, some people call this like the crab claw method, because if you look at the arches, they look like a little crab claw, you know, kind of thing. So, or actually it's more like this. Okay, but anyway.
You call it the rainbow effect.
Yeah, people call it rainbow method too and stuff like that. Yeah, different names for it. It's really the distributive property though. That's what our boring old mathematicians call it. So, all right, nothing pretty. Anywho. All right, so we're going to multiply 2x times 5. Again, I'm going to write this very explicitly. You do not have to write it out this, you know, like exactly as I do. But if it helps, oops, it's a minus 3 times positive 2, so it becomes minus 3x times 2x plus, oops, and it's minus 2 times 5. So, well, I can just do that. Negative 2 times 5 plus, and then negative 2 times negative 3x. Okay. So again, 2x times 5, 2x times minus 3x, negative 2 times 5, and negative 2 times negative 3x. Okay. And so let's see, that becomes then 2x times 5 is 10x minus 6x squared. 3 times 3 is 6, x times x is x squared, minus 10 plus 6x. Negative 2 times negative 3, positive 6. Oops, sorry. And are there any like terms here?
Yeah.
Yes, the 6 and the 10, right? 6x and the 10x. So that becomes, if I add those two, right, it's 10x and then plus 6x. Yes, there's a minus sign here, but the plus sign's in front of the 6. Okay, there's a plus sign in front of the 6, so it's 10x plus 6x, that's 16x minus 6x squared minus 10. And then if you like, you can put it in descending order, so it'll be negative 6x squared plus 16x minus 10. Okay, but either one of these is acceptable there for the simplifying. Okay? So is that stuff ringing a bell? Hopefully? Yes? Okay, good. It feels a little comfortable, I hope. So maybe a little more comfortable for some of you if it's tough. I hope that's true too. But okay. So that's what we're going to worry about for today then. So we'll stop there. Any other last minute questions? I'm still going to get to you. I just want to give everyone a chance to.
For that last part,
yes.
about the 10x.
Right here?
Can you just do that to begin with? Like, when you...
Oh yeah, you have to do this part?
Yeah.
Oh yeah, no. I do this just to make sure you can see exactly what's being multiplied together. But if you're comfortable going from here to here, skip this little step. Okay? I will leave that up to you. But Garrett, you start getting them wrong, feel free to start doing this then to help you out. Okay? But yeah, skip it if you want.